everyone. So I hope you all are fine and doing well. So today we are going to learn the variational autoencoders and we are going to build an encoder. Okay. So we are going to learn about the codes and do some theory. So before that, just I want to tell you two things. First is that be consistent. Okay. If you have started this lecture, then complete it. Okay. And second thing is that if you really like this video, then please like, share, subscribe my channel. Um, so let's go on this journey. So let's start about the variational autoencoders. So if you haven't watched the previous videos, then link in the description. So go and watch those videos so that you'll have a better understanding. And this is going to be the eighth lecture. So now we are going to learn about the variational autoencoders. That what is it? What the variational encoders is? Autoencoders is. So actually, variational autoencoders is the modified form of autoencoders. Okay. So what autoencoder does? It actually encodes the thing and again the decode the thing. Okay. So I hope you have got idea uh, and you can just watch the previous videos so that you will have a better idea that what an autoencoder is. Okay, now we are going to learn about the variational autoencoder. So by variational autoencoder you will be having some idea that okay, there is something which will be vary in this thing. So that thing we are going to see. So the two paths that we need to change in the autoencoder is the encoder and the loss function. Okay, so we are going to change the encoder itself and the loss function, and we will be seeing this thing. Okay, so actually, what the autoencoder does? The autoencoder actually does that it actually map every image in a point. Just see this thing. What it does that it maps every image into a sample point, something like this. Okay, it this is the image and it is mapping it to a sample point. But what what a variational autoencoder does, that it makes a graph. Okay, I don't know how to like you can just see graph, Gaussian graph. We'll see Gaussian distribution graph. Yeah, you can see here, of course. So this type of graph, actually it okay, we just copy it and I will just paste it here. So it converts into this type of graph. So this image is actually converting in this type of graph. Okay. So I hope you are getting the idea that this is the autoencoder. This is the variational autoencoder. This is the encoder. Okay. So that is the difference. That is the main difference. You can see that it is encoding in the one point, one sample, but it is actually doing it in a uh, probability way, or it is doing it in normal distribution. Okay, so that is the main thing. Okay, so now the multivariate normal distribution. So what is the multivariate? Means there will be multivariable, and the normal distribution is actually this distribution is there. That there is a graph. You can just see it in 2D. That there is a graph which is distributing like this. So this is actually called the Gaussian distribution. And there are two things. There are two things. Actually, the mean. There are two variables. You can see the mean and the variance. Okay, so we will be seeing this thing. Okay, you can see this thing, that this is the multivariable normal distribution. You can say a standard normal distribution. If you have some idea of probability, then you can just you can just know it. Okay, you can just search it, that what is the normal distribution. You can learn from Byju's or anywhere you want. So you will have more idea about it, that what is going on actually. So for now, you just have some idea that the graph which goes up and goes down, something like that, that is called the standard normal distribution. I hope you got the idea. Then the concept of the normal distribution extend more than one dimension. The probability density function of for the multivariable normal distribution, also called the Gaussian distribution. Okay, So just don't like for now, don't see this formula. This seems lengthy, but okay. For now, we have just two things to know that what the encoder will do in this case, that it will actually give the two values. One value will be the mean vector and second value will be the variance vector. Okay, so to summarize the things, encoder will take the image. It will take the image and encode into the two vectors that together define the multivariate normal distribution. Means actually it will give two vectors. First will be the z mean and second will be the z log variable. Something like this. Something like this. You can just have idea that encoder has taken the image, then it will convert into two different vectors, and then two different vectors will make something like a sample, and then it will create the decoder. So actually what is happening? What is happening in it? Okay, so you can just see that the logarithm of the variance of the each dimension. If you have some idea of the probability, then you will be knowing that the variance is there. So if you do the log, then that will be the z log var, मतलब variance. ठीक है? Okay, fine. Then there is a formula z is equal to z mean plus z sigma multiplied by epsilon. If you are not getting in one time, then it is okay. It is completely okay if you are not getting it completely. So actually, these are some relationship between these things. This is actually formulas, okay. But I just want you to convey some theory that what is actually going on and why we are finding these two things like z mean and then again the z log variable. Why we are finding these two things? So first thing is that, like, why does this small change to encoder help? Why we are doing it? So, since we are sampling a random point from the area, so now we have converted a whole image into somewhat a area or a probability distribution. So, what it will do that we are sampling a random point from an area around the Z mean, means the decoder must ensure that all points in the same neighborhood produce the similar images when decoded, so that reconstruction loss become small. So that is the thing about the z mean. Actually it will take the mean. That is the very simple thing. I hope you got it. Now what about the z log variable? Okay, so we will be seeing this. Okay, so actually chat gpt has explained in a very easy way, so that's why I'm using it. So what is the, like, just see that I auto encoder actually, if you don't know about auto encoder, then just continue with this thing. Like it have the encoder and decoder. And encoder, what it does, that it convert the input data into latent space, and then decoder does that it reconstruct the original data from the latent space. Okay, so I hope you got it. um, then there is a probabilistic twist. What is the twist? That variational autoencoders introduced a probabilistic approach. What will do this probability? Actually, probability will does that it will do the randomization. It will mix up the things, sort of. So instead of encoding data deterministically, it encodes the probability distribution. Okay, so you will have some idea that okay, it is doing some graphs by the data. Okay, then there is that represent the latency space using a mean. Okay, so there is a mean and a variance. Two things are there, and that assume the multivariate Gaussian distribution for simplicity. Okay, so what it does actually, that to backpropagate through the sampling process, the reparameterizations trick is used. Okay, so just see this thing, that what is the parameterization. So it is actually that it introduced the okay. So challenge is that training makes the back propagation difficult. Okay, so sampling from a distribution actually make it tough, that how it back propagate. And again I hope you got the back propagation is, because back propagation is something that it gives the feedback loop, something like feedback loop. Okay, So instead of sampling directly, reparameterize the random variable using the deterministic uh, transformation. Okay, so express a sample in function of deterministic part and a random part. You can just have a look here. Just see for the Gaussian distribution, there is mu and sigma. So sigma square is there. That is like a standard deviation square is equal to variance. Okay, and mu is the mean. So okay, mean is the deterministic part and the random part is, I think, the standard deviation and like variance. Okay, so how it is varying, it is called the variance. Fine. So during back propagation, gradients can now flow through the mean and variance parameters, facilitating the model training. Okay, so I will just tell one thing that if you are if you are getting it 20, 30, 40%, then it is okay for the first time. It is quite integrate thing to understand, but I hope that you are getting it 20, 30, 40%. Again we'll be seeing this thing, then it you just watch the video again, so that or you can just follow some other resources also, so that you'll have a more uh, understanding of what the things are going on. So now we are going to see about the building a variational autoencoders. So we are going to build a new version. So here is the code actually. You can just have a look. Okay. So just copy paste it here. Okay. So so you can just create a code. I will actually give its link in the description. Actually, you can also search it actually. Wait. Um, Generative deep learning. Okay, so you can just have a look here, and here in the notebooks you can go, and now in the three part there is a variational autoencoders. So you can see that autoencoders is there, and I think this is the file. So you can just have a look. I will be just giving it it's the its link in the description, so not to worry. Fine. So let's see this thing now. So first we are going to create a new type of sampling layer, that is going to allow us to sample from the distribution defined by Z mean and Z log variance. So what I actually Z mean does, that it gives a point, and what the variable does, that sampling will not go too far from it. Okay, so it will be something like near to it, so that that reconstruction work will be better, so that it will reconstruct the things near to it. Okay, fine. Then there is a class. We are making a class. So that class is sampling. So we are going to call cell for input, and then what the input will go, it will go into the Z mean and Z log variable. So, so some people have said that how to understand this thing. So I'm going to define, just make you understand point by point. So then there is a batch. Though that is what actually do that. Hold on. So actually, this thing is going to say define the shape of the Z mean of 0, and there is a shape of Z mean of 1, so that is going to be the dimension, and there is a epsilon. So you can just have a look here. Then there is a parameterization, that is called that gradients can back propagate freely through the layer. Okay, so its overall mean is that the gradients can back propagate freely through the layers. So that's why the reparameterization trick is there. Then we have this long code. So first let's one thing we are going to do, we are just going to actually this is actually a formula. From here it is showing a formula. So let's have a look on the chat GPT that it will be defining it more. Teach me. So you can see that sampling is a custom keras layer. It actually making a keras layer, and then call is the method. It is actually calling that layer is calling about for the inputs. Okay, and then there is input parameters like in what the you will give some input. Let's see a and b. So that a and b will be the a will be maybe the z mean and b will be the z log variance, and then there is a batch. What is the batch? It will actually retrieve the batch size. Okay, it will retrieve the batch size, and this code will actually retrieves the uh, dimensionality. Okay, fine. Then there is a random sampling. Okay, so it will actually generate the random sample from the standard normal distribution with a specified shape. Okay, so we have got the batch size and dimension. So we got the batch and dimension. So it will actually what it does, it will does that it will generate the random sample of this batch size and dimension. Okay, I hope you got it, and applies the reparameterization trick to sample from Gaussian distribution. Okay, so it will does that reparameterization trick, so that it will actually sample from the Gaussian distribution defined by z mean z log variable. Okay, so this is actually the formula. This is the shorter form. Okay, so this is return z mean. Then this, okay, sorry, return is there and z mean is there, I think, and this is the formula actually. Okay, then the sampling layer and ensures that the sampling operation is differentiable and allowing the gradients to flow during the back propagation. So I hope you got some idea that what the code is about. Then there is this thing. So for this thing, I have made a, you can say I have made a picture. So like there are three convolution. You can see that there is three convolution. Let's see this table first. Then we'll be going to that. There is three convolution layer. Then it will flatten. And after flattening, what it does that it will go through the z mean and z log variable. And after that, it will make a sample. So what it does mean? It is actually doing that. It will doing that. It will create the z mean z log variable and then go to the z. Okay. So here is the picture of it. You can see just here that there are okay, just delete this thing. There are three convolutional layers, and it will go and flatten up. And after flattening up, it will go to the z mean and z log variable, and after that it will make a z. So that is the simple thing it is doing. The auto encoder is doing, auto encoder in variational auto encoders, the encoder is doing actually. Fine. So I hope you got the idea. In the next part, we'll be seeing that what is the KL divergence term, the loss function we'll be seeing, and we'll be in the further videos, we'll be building a whole variational auto encoders that can recreate the images, and actually variational auto encoders can generate the new images. So that is the good thing about this thing. So I hope you got this thing. This was somewhat complicated, yes. Um, I understand this thing, but if you got it 30-40%, it is okay. 50%, it is okay. You do some your own research also, because learning from yourself is also helpful. I hope that I'll be able to make you understand the things that what is going on. So thank you so much. If you like this video, then please like, share, subscribe. Thank you.